Alright, so for this video here, you're going to be able to skip around and go to any place you need to go. Normally you can't skip around in here, but for this one you can. So you can just skip ahead to where you need to go for whatever we didn't cover in class. Alright, so think back to Algebra 2 are just some of the methods that you used when solving equations. You would do something like isolate the variable, right? Like if you had an equation where you have like 3x plus 5 equals 4, you basically are just going to get x alone, and then that's your answer, right? So you used to isolate the variable. You would do things like take the square root. Like if you had x squared equals 10, you would take the square root of both sides. You would do things like factoring, like maybe you have a quadratic and you factor it, and then find the solution. So all things like that, and come up when you are solving equations, and they're going to come up with trig equations, but you're going to see them with trig functions, right? So instead of x, we're going to have stuff like sine x. Instead of, x, we're going to have things like cosine x and things like that, okay? All right, so here we go. So today in class we practiced doing these things. So like if I want to do letter A right here and say, oh, the sine is equal to 1/2. The sine of some angle is equal to 1/2. I go to my unit circle and I say to myself, oh, the sine is the y value. So there it is. That must mean I use pi over 6. And remember A, S, T, C. So there it is again. So the answer is 5 pi over 6. So x must be pi over 6 or 5 pi over 6. So a lot of times you get two answers. All right, cosine is negative radical 2. So I look again. So negative radical 2 over 2. I look at that and I'm like, okay, ASTC, it has to be in the second quadrant. So there it is. So 3 pi over 4 is one of my answers. And down here at T, there it is again. The x value is there at 5 pi over 4. So x would be 3 pi over 4 and 5 pi over 4. Now, we could answer in degrees as well, but I'm going to ask you to answer in radians. That's kind of like the normal way. All right, so let's go tangent. Now, tangent being 0 is a little bit harder to figure out. The tangent is 0, so remember tangent is the y value over the x value. So if you want that to be 0, then you'd have to have 0 on top and then some kind of number on the bottom. Well, the only place that I see the y value is 0 is right here. So 0 over 1 would be 0, and over here, 0 over negative 1 would also be 0. So my answers to that question are 0 and pi. Up here, this is backwards, so that's not right. All right, secant is 2. So when the secant is 2, you have to transform this. Secant is not something that you know a lot about, but you do know a lot about its reciprocal. The reciprocal of secant is 1 over cosine. I'm sorry, not the reciprocal, but the secant is the same as 1 over cosine. And so if the secant is 2, that means the cosine is the reciprocal 1/2. So forget about this, use this instead. So when is the cosine 1/2? I would go over here and I would take a look. The cosine is 1/2. I look in the first quadrant. There it is, so pi over 3. And then the fourth quadrant, x value, there it is, so 5 pi over 3. So x would equal pi over 3 and 5 pi over 3. All right, so now you're also going to run across sometimes when you have this plus or minus symbol. Like whenever you take the square root, remember, you put plus or minus in front of your answer. So you are going to run into that situation, and so then you'll get even more answers than 2, usually. And so when we do that, the cotangent is -1, or positive 1. Now cotangent, remember, is the reverse of the tangent, so it's reciprocal, so it's the x over the y. So I need a place where the x and the y match, because that's when the x and when I'm going to get 1 from a fraction. The top and the bottom match, they equal 1. So that is all these places, radical 2 over 2, radical 2 over 2. So all these 4 places right here are places where the cotangent is equal to 1 or -1. Because it's equal to 1 when they both match, it's equal to -1 when one's positive and one's negative. So I'm going to name those 4 places. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So every once in a while you will get more than that. All right, and then this guy, tangent equals negative radical 3 over 3. So for that, I want you to remember these facts that we went over before. Tangent radical 3 over 3 comes from having the tangent of pi over 6, because we take this y value, put it over that x value, and it comes out to radical 3 over 3. Pi over 3 produces this tangent, any kind of 60-degree angles. So since we're asking about radical 3 over 3, we have to look at a 30-degree angle, and it has to be in a negative place. So 30-degree angle, and where tangent's negative. So if I want tangent to be negative and 30-degree angle, then I would choose 5 pi over 6. Tangent's positive here, so I'd go over here. Tangent's this guy right here, 30-degree angle. So x equals 5 pi over 6, and it's also 11 pi over 6. Whoa. I don't know what I was writing there. Alright, so these are the places where this would be true. Alright, so that's the real like the basics of it, but we're going to go ahead and this is what's gonna our problems are going to look like in the end. I just wanted you to see how to solve those simple things, because then that's going to lead you to know how to get the answers to our problems. All right, so in class we probably got this far and we did a few of these problems, but I'm just going to go ahead and do them, skip them over if you want to. So right here I want you guys to see this problem as, we got 5 cosine x minus 1 equals 3 cosine x. Pretend those cosines were x's, right? We'd have 5x minus 1 equals 3x. If this were an algebra problem, you'd probably move this 3x over here with the 5, move that 1 over there, and then you'd solve it that way. By move, I mean, subtract 3x from both sides and things like that. So I'm going to take away 3 cosine x, take away 3 cosine x. So I have 2 cosine x. Minus 1 equals nothing. All right, so I'm going to add 1 to both sides. So 2 cosine x equals 1, and then divide by 2, so cosine x equals 1/2. And this is exactly what we did on the last page. I go to my unit circle. 1 is the cosine equal to 1/2. It's at pi over 3. And also, let's see, ASTC. Cosine is 1/2 right here. So pi over 3 and 5 pi over 3. So that's my answer. I just write that down. X equals pi over 3 and 5 pi over 3. Now, you can also graph. Once you get right here is a good place to graph. If you go to Desmos and graph this, look at that. There's pi over 3, there's 5 pi over 3, and you can click on those spots and you can see the answers on Desmos as well. But it's good to have everything on one side, and then you can just graph the equation. All right, for example 2. Imagine you had this, x plus radical 2 equals negative x. This is the equation that I'm imagining. So I'm going to isolate the variable. I'm going to get the x's together and the numbers on the other side. So I'm going to add sine x over here, add sine x here. So sine plus sine is 2. 2 sine x plus radical 2 equals 0. So move the radical 2 over. Divide by 2. So sine x equals radical 2 over 2. Oh, that's a 45-degree angle. So I need to go find all the angles where the sine is radical 2 over 2. So there it is right there, the y value, pi over 4. And sine is positive in the second quadrant, so there it is again, 3 pi over 4. All right, so pi over 4 and 3 pi over 4. So a lot of times you have 2 answers. Every once in a while you don't. Every once in a while you have more than 2. All right, so let's look at example 3. Imagine this was the problem 3x squared minus 1 equals 0. I would move the 1 over, divide by 3, so I'd get x squared equals 1/3. Then I would go and take the square root of both sides, right, to keep solving that. And we'd get x equals plus or minus the square root of 1/3, right? So we're going to do the same thing here. We're going to move the 1, divide by 3, so I get tangent squared equals 1/3. Now I'm going to go and do the square root of both sides. But the square root, be careful. Square root of both sides, this tangent comes out. Remember, you put plus or minus. Now, you know the square root of 1 is 1, and the square root of 3 you don't know. Now remember, this rationalizes, so you multiply by radical 3 on top and bottom, you will get radical 3 over 3. So, on the last page, we saw that this comes from a 30-degree angle. So when you divide the y over the x for 30-degree angle, you get radical 3 over 3. The tangent of 30-degree angles are radical 3 over 3. It might be positive or negative, but that's what they are. So I want the tangent to be positive radical 3 over 3. Or minus, actually. So forget about that. So I'm going to have to look here. All the 30-degree angles. I'm going to answer pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, number 4, secant square, 3 secant squared minus 4 equals 0. So again, this is kind of like the last one. I'm going to move the 4 over, divide by 3, so I get secant squared equals 4/3. I'm going to take the square root, so square root, square root. So I get secant equals plus or minus, the square root of 4 is 2, and on the bottom is radical 3. Now I'm not going to rationalize this yet because I don't like that secant, right? But secant is the reverse of cosine. So if the secant is 2 over radical 3, then the cosine is the reciprocal of that. It's plus or minus radical 3 over 2. So this is something I recognize, and I didn't really need to rationalize because when I flipped it over, this is exactly recognizable as all my 30-degree angles. So what is the cosine plus or minus radical 3 over 2? Right here at pi over 6, 5 pi over 6. Here it is again at 7 pi over 6, and there it is again at 11 pi over 6. So really it's the same answers as example 3. 6, pi over 6, 7 pi over 6, and 11. Alright, and if you graph this, like if you just graph the original because it's equal to 0, look at all these answers. One answer, another answer, another answer, another answer. Because we're doing answers between 0 and 2 pi. That's one rotation of the unit circle. So you can always check it on Desmos. All right, last 4 problems here. So now we're going to be approaching something else that we have to think about. When I look at this problem here, you never, ever, 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 ever want to like cancel something like that. Don't do that because you're going to lose one of your answers. Just like if you had like, you know, x squared equals x, you don't really want to cancel an x like that because you lose some of your answers. What you do is you bring everything to one side and you factor. So I'm going to bring this over to this side. Cotangent cosine squared minus 2 cotangent x equals 0. All right, so notice here we have something in common. I have a cotangent and another cotangent. I'm going to factor cotangent out. So then I get cosine squared minus 2. Okay, so when we factor, then we set each part equal to 0. So this part, I get cotangent x equal to 0. I'll figure that out. Set this equal to 0. Cosine squared minus 2 equals 0. Add 2 to both sides, so I get cosine squared equals to 2. Do the square root. Get cosine x equals plus or minus radical 2. Now wait a minute. It's supposed to be radical 2 over 2. I don't recognize this answer. In fact, radical 2 is the number 1.41 and so on. This is too big. A cosine graph, and cosines on the unit circle, never get above 1 or below negative 1. They stay between 1 and they stay between negative 1. This is too big. This literally has no solution, that part of my problem. So that actually makes it easier for me because I don't have to do anything. This part's dead. But over here, cotangent is equal to 0. Now remember, the cotangent is the reverse of the tangent. Cotangent is the x over the y value. So it's x over y. If this is going to equal 0, then I need the top to be 0 and the bottom to be a number. So I need to look for places where the x value is 0. So let's go back. When is the x value 0? Not there. Here it is, pi over 2 and 3 pi over 2. Alright, so my only answers are pi over 2 and 3 pi over 2. So both of these things could have produced answers. It just turns out this part right here didn't produce anything for me. I didn't need it at all, but I didn't know that until I did it. Alright, now example 6. I'm going to factor in example 6, but I want you to recognize it's a different kind of factoring. We got 2 sine squared minus sine minus 1. So this is like having 2x squared minus x minus 1. So notice that the sine is kind of counting for my x right here. So if I was going to factor this, it's just like a quadratic. I would go like this. 2 parentheses, there's no GCF. I would say to myself, 2x squared means 2x x. The only thing that multiplies to 1 is 1. And I have to decide my signs. Right? So for my signs, I would say, this is getting me a 2x, this is getting me a 1x. I want a negative 2 plus 1 because that's going to give me my negative 1x in the middle. So this part's negative, this part's positive. Now that we have it factored in this, like, back in our algebra world type of factoring, I know that the sine x is just in place of this x right here. So I just go back to sine x plus 1 and sine x equals 0. So that way, All right, so that way, if you take it back to an algebra problem that that you know how to do, then it's going to be a little bit easier for you to see how to factor it, and you don't have to deal with it with all the sine and cosine business. You do that and kind of like you write its the problem in an algebra way, and then you can know how to do it with the trig problems, right? So this, I set each part equal to 0. 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. All right, so from there I have to solve these things. I'm going to take away 1, divide by 2, so I get sine x equals negative 1/2. I'm going to add 1 to both sides over here, so I get sine x equals 1. These are both valid answers. All right, so let's go for it. When is the sine negative 1/2? Let's go take a look. Sine is negative 1/2. It has to be in these bottom quadrants. So the y value right there and right there. So 7 pi over 6 and 11 pi over 6. So I'm going to list all my answers. 7 pi over 6 and 11 pi over 6. And when is the sine 1? So I'll go back here. When is the sine 1? So the y value is 1. There it is right there. So I'm going to say pi over 2. And look there, on my graph, 1, 2, 3 answers I was getting. If you graph this on Desmos, this equation up here, you'll see that there's 3 answers, and you can actually click on them and know the answers, but I need to see your work. All right, last 2 problems here. So, cosine squared, 4 cosine equals negative 3. So if I make this into like an algebra problem, x squared minus 4x equals negative 3. Hopefully that helps you recognize that I just need to bring this 3 over and factor. Watch, x squared minus 4x plus 3 equals 0. It's just a factoring problem. 2 parentheses, x and x, 3 times 1 makes 3. Both minus are going to work because this is going to make negative x, this is going to make negative 3x, which makes my negative 4. All right, so let's map it out to what we have. We've got cosine in places of x's. So I'm literally going to use what I did right here, and instead of x, I'm going to put cosine x. So cosine x minus 3, and cosine x minus 1. Okay, so here we go. Cosine x minus 3 equals 0, and cosine x minus 1 equals 0. So this means that cosine x equals 3. This one over here, cosine x equals 1. So cosine x equals 3 is never possible. Remember we talked about up here, it has to stay between negative 1 and 1. So there's no solution coming from this. And what is a cosine 1? Just go to my trusty unit circle, and there it is. The x value is 1 when x equals 0. All right, so my only answer here is x equals 0. That's it. All right, this last one here. So in this last problem, I have an issue here. I got cotangent squared and I got cosecant. Ooh, these don't go together. But do you remember this identity? Every once in a while you have to change something to make it work. So do you remember the identity that says, pen back, 1 plus cotangent squared equals cosecant squared? So we're going to have to change this. I'm going to replace this cotangent. I can't change the cosecant, but I can change the cotangent squared to something else. I'm going to change cotangent squared to cosecant squared minus 1. So let's do it. 3, and I got cosecant minus 1 minus 5 cosecant equals negative 1. So at least now everything is the same item. They're all cosecants. Okay? So let's work this out a little bit. 3 cosecant squared minus 3 minus 5 cosecant equals negative 1. So let's clean it up. 3 cosecant squared. I'm going to put this 1 next. Minus 5 cosecant. And I would write minus 3. Well, we'll go ahead and write it. Minus 3 equals negative 1. So I need to add 1 over here. So 3 cosecant squared minus 5 cosecant minus 2 equals 0. So again, this maps to the algebra problem 3x squared minus 5x minus 2. So if I can factor that, then I can go back and plug in the things that I need. So 3x and x, the 2 here and the 1 there, that makes 6 on the outside, 1 in the middle. 6 is negative, my 1 is positive to get my negative 5. All right, so let's go back and put cosecant in there. So I have 3 cosecant plus 1, and I have cosecant minus 2. All right, so if I set this equal to 0, 3 cosecant x plus 1 equals 0, I will get cosecant x equals negative 1/3. If I set this equal to 0, I will get cosecant equals 2. And you can set it to 0. I'm just talking about doing this part, but then kind of doing the rest in my head. All right, so let's take a look. Cosecant is I don't like cosecant. Cosecant, though, is the reverse of sine. So this would mean that the sine is negative 3, because if I flip 1/3, I get negative 3. This would mean that the sine is 1/2, because if I flip 2, I get 1/2. Sine negative 3, never going to happen. All right, the sine only gets as big as positive 1, as low as negative 1. It stays between 1 and negative 1. So great, nothing to do. But this one I can handle. When is the sine 1/2? I go to my unit circle, take a look. The sine is 1/2 here, and it's also 1/2 here. So pi over 6 and 5 pi over 6. My answer, pi over 6 and 5 pi over 6. And there you have it. Let me know if you have any questions. Email me or come to office hours. And I'll see you next week. Bye-bye.